recording.
No,
Yeah, tell me.
not a recording only. I was saying.
Yeah. Okay, I just started. Okay, so as I told you, okay, so till now in India there is for the 5G there is no spectrum allocation. If the spectrum allocation happen, then N78 band is there for the spectrum allocations. Okay, in India only. Now, okay, so X2 handover. So X2 handover. So if we talk about serving inode B, okay, so in each and every inode B have their neighbor table list. Okay, inside the inode B. So in which PCI is there, neighbor inode B ID is there, and some other IP address is there. So okay, for the communication purpose. So and both inode B have a X2 connection. X2 connection in the sense both serving and target inode B both have a X2 interface between them. So using that they can talk. Okay. So now, suppose any event trigger. So in LT we have a A1, A2, A3, A4, A5, A6, and B1, B2 events is there. Okay, so generally A1 events is used for stopping the measurement report. A2 event is used for the starting the measurement report. Okay, so what is measurement report? So measurement report is nothing but once UV lose the serving connection, or UV going away from the inode B. Okay, so that time what happens? So your RSRP range, okay, it's decreased once you away from the inode B. So in this case, there are some event as I told, A1, A2, A3. Okay, so using that UV report the measurement to the serving inode B, and in that measurement report, UV report the target cell PCI value and RSRP value. Okay, so each and every event A1, A2, A3, A4, A5. Okay, there have some specific triggered and some threshold value is there. Okay, so A1 is event is used for stopping the measurement report. A2 is for starting the measurement report. A3 event is for triggering intra or inter handover. Okay, this inter frequency or intra frequency also using A3. A4 event is used for carrier aggregation to add the survey secondary cell. Okay, you will learn in upcoming session for this what is carrier aggregations. And A5 event is used for selecting the uh, serving cell, which is the better. Suppose if I have a 20 megahertz in band 40 and I have a 5 megahertz in band 5. Can you mute yourself? Hello. Okay. Okay, where I am. Hello. हेलो.
हेलो सर.
या मैं क्या बोल रहा था? A5 event, am I right?
Yes sir, A5 event.
Yeah, so in A5 event what happens when you have a suppose in some operator have a 20 megahertz frequency in band 40, and some they have also uh, uh, they have band 5 also, in which they have a 5 megahertz only. Okay, so when any user is connected, okay, in the LTE case, so then your once your frequency is increased, okay, then your coverage area is lesser. Once and it's we already learned everything in our engineering that frequency is inversely proportional to wavelength. So in our case, if we increase the frequency, okay, then our wavelength is decreased. It means our coverage area is decreased. So band 40 have a 20 megahertz, but its coverage area is lower than band 5. Okay, So band 5 only we have a 5 megahertz. So what happens once any UV is connected? So it's first due to high coverage, okay, it's connect with the band 5 only. Then band 5, once it's UV is starting any data, that time it's move from band 5 to band 20, okay, because band 20 have a 20 megahertz. So in 20 megahertz we have around 100 RB, okay, but in the case of band 5 we have only 5 megahertz, and in 5 megahertz we have only 25 resource block, okay. So if I event use over there, then A6 event is used for in a carrier aggregation case from secondary cell handover, okay, from one secondary cell handover to another secondary cell handover. And B1 and B2 event is used for inter-rat handover, means from 4G to 3G, or suppose in the 5G case from 5G to 3G. So B1 event is used for generally for the measurement report of the inter-rat, okay, and B3 event is a handover purpose only. So now this is the X2
Hello?
handover. Hello.
Hello, sir. Can you explain the handover between two secondary cells?
Secondary cell. So once you learn the carrier aggregation, that time only it's coming. So what happens in the RRC reconfigurations? Okay,
Okay.
from the network side we configure the A6 event. So A6 event we configure based on that parameter RSRP value and all. Once UV meet that criteria, okay, for the secondary cell, then UV report that measurement value in the measurement report from UV to enode B, okay. So
Yes.
enode B now get to know, okay, so this UV triggered the A6 event, okay. Then based on that UV check the reported PCI value, okay. Then again network send the RRC reconfigurations, okay. This is also called as a handover command, okay, but handover command is nothing but it's inode B send the RRC reconfiguration message to the UV in which secondary cell handover target, I mean to say target cell, target secondary cells information is present, okay. Based on
Okay.
that UV attach with that secondary cell, and UV send that RRC reconfiguration complete message to that secondary cell target,
Oh,
okay.
okay.
So this is the X2 handover. So X2 handover takes place only when two inode B is connected using X2 interface. Okay, so in some case, okay, there is two inode B. Okay, nearby only two inode B is not connected with the X2 interface. So that time what happened in this condition also UV is able to read the target cell PCI. So that time UV report that measurement value, okay, using A2 event. So based on that inode B get to know first inode B receive that PCI value and RSRP value. They checked that PCI value from the inode B neighbor table list. Okay, if inode B found that PCI value, then it's okay. If you then you inode B triggered the X2 interface. But in our case now, inode B don't find any value for the target cell PCI or neighboring information. So now what happened? Inode B send that information to MME, and MME send that that information to respective uh, target inode B. Okay, so now what happens? You request for the handover. Okay, then target inode B if acknowledge that value based on admission criteria. Okay, there is not necessary that always target inode B accept the handover request from the serving cell. Okay, it's not necessary. Suppose in some of case, suppose target inode B have a high number of resource, okay, high number of resource utilization, so that time handover will not happen. So now UV again report the measurement report for some other target inode B. Okay, these things happen in generally in mall and some event area, and generally in our city area, this kind of things. But generally X2 interface is there always, okay. So this is S1 handover, okay. So now, anybody have any doubt till now for X2 or S1 handover? So generally this kind of question they ask, so you can tell during the interview that X2 interface is happen when two inode B is connected with the X2 interface. Otherwise, inode B perform the S1 handover. Okay. Anybody have any question in this? Hello, can anyone respond?
No, sir. You can go further.
Okay, so next, now in call flow. Okay, so call flow. So before call flow, they can ask only three kind of questions. What happen when a device power on? Okay, this is the first question during interview. And what is initial acquisition? This is the second question. And what is the LTE call flow? Okay, this is the third question. So these three questions they definitely ask you during the interview. Okay, and third one is what is LTE architecture and all. Okay, those kind of question. So generally in any interview, if you are experienced, if you are freshers, okay, any stage, they'll ask you this kind of questions. Okay, so first, what happen when a device power on? Okay, so here when a device is power on, it is not aware of the full system bandwidth. So it does a frequency search, and it's first sync with the DC subcarrier. Using this information, device read the central 6 RB. Okay, from that you will read the primary and secondary synchronization signal, and you after this you is able to read the PBCH. Okay, in this using PBCH you is able to read the MIB. Okay, all are contains in the central 72 subcarrier of the system bandwidth. Initially, network allowed device to demodulate just this central region. So means initially you is able to read only this central region, what PSS, SSS and PBCH. From the PBCH you will get the information about MIB, master information block. Okay, once demodulating this information, PSS, SSH, and MIB, device is get the RSSI value using which it's initiated the initial acquisition process. Okay, it does PSS and SSS for the time and the frame synchronization. Using this information, uh, devices also find PCI value. Okay, from the PSS, because there is a PCI value have some formula like PCI is equal to 3 SSS plus PSS. Okay, this is the formula. Based on that, you is able to find the PCI value. Then device subsequently received the MIB and SIB from the network, and then initiate the process for the cell selection. Okay, this is the your uh, this is the process when device of first time power on, and after switch off, and if you switch on the device. Okay, then what is initial acquisition in LTE? Okay, so initial acquisition process was some steps like device was first power on, then it search for the P element. Okay, so now it's scan the supported bandwidth respective with that P element. So from where you will get this P element information? So once you buy the SIM card, so in that SIM card, operator push some profile. Okay, that profile in which whatever subscription you took, and other information like INSI, and for that INSI they have some key value. That key value is used during the authentications, and PLMN info, supported PLMN info. So generally if you buy a SIM card in Maharashtra, so for the Maharashtra they store the home PLMN. Okay, and if you are moved from Maharashtra to Gujarat or some another Delhi or Bangalore, so for that you are now you are in a roaming PLMN. okay, because each and every state have a different p element. Okay, so those information is present in sim card only. So first of all, you will search the once device power on, it search for the p element. So first of all, you will try with the home p element only. It scan the supported band within the respective p element. It scan the ERFCN. So ERFCN is nothing but the central frequency of the particular band. Suppose if I'm talking about band 40, so in band 40, we suppose we have a 20 megahertz. So in that 20 megahertz, uh, uh, central frequency is nothing but the 0 to 20, and our middle frequency is the 10 megahertz. So whatever frequency the 10 megahertz have, those frequency, there is some calculation using that you can calculate the EARFCN. Okay, then based on that ERFCN, it makes the priority table using sorry. So you we have that PLMN info and supported band list. So now UE is able to make a priority table based on RSSI value. Okay, with respective ERFCN. Okay, then so different band have a different ERFCM. Okay, so based on that, first priority, okay, first priority ERFCM, you will try to acquire the cells. So for that, you will now read the first. You will already read the PCC, PSS, SSS, and MIB. Now UV is reading SIB. Okay, from the SIB1, UV is able to get the cell selection criteria. Okay, based on that, that cell selection criteria is full, then and only UV is able to initially acquisition complete with that cell. Otherwise, sometime that criteria not met, then UV went with the second priority. Okay, so this is the initial acquisition process. And now LT call flow. So in LT call flow, once anybody asks you, then you can directly start with the MIB SIB directly. No need to tell them like once UV power on, then you will read the PSS, then SSS. Based on that, you will calculate the PCI, then you will read the MIB, then UV makes the table for each and different frequency, then UV makes the table for that different frequency. Then from that table, you will select any PCI priority PCI first. Okay, then you will try to sell selections on that after reading SIB1. Okay, this information is not required. You can directly tell for the LTE call flow. You will read the MIB, and then after MIB you will read the SIB1. From that SIB1 you will get the information of the cell selection. Then once you will cell selection with that inode B, then you will read the SIB2 and SIB3, 4, 5. Okay, this information, then you will based on that SIB2, you will get the information of the random access, how to do random access. Okay, so based on that, you will perform the random access message. Okay, so in this screens you are able to see here random access preamble. Are you able to see? Hello? Yeah, so now you will send the random access preamble set this second message. Based on that, you will respond the preamble response. Okay, based on that, in which different information is present. This preamble first random access preamble, this is the we called as a message one in telecom language. Then whatever response we receive, we called as a message two. Then so here, this after sending the message one and message two, your SRB0 connection is established between UV and inode B. Okay, so all the SRB information is going from the RLC transmit TM mode only. Okay, so for that AM or UM mode is not required. So this information only bypass. Okay, there is no security required for this information for random access preamble RARP. Okay, then UV send the radio RRC connection request message. Okay, this is we called as RRC connection request message. Based on that request message, node B respond the RRC connection setup. In that information, you is find the information about the SRB. Till now, you have a SRB 0 connection. Okay, till you will receive the RRC connection setup. Once you will decode the RRC connection RRC connection setup message, from that onwards, your SRB1 is established. Now there is no need for the SRB 0. Now, based on that RRC connection setup, you will respond the RRC complete attach request. Okay, so this message RRC connection setup message we called as a message 3. This RRC connection setup message we called as a message 4, and this is your RRC connection setup complete message is we called as a message 5. So in RRC connection setup complete message, UV send the piggyback NAS message called as a attach request and PDN connectivity request for the default bearer. Okay, so once inode B receive these informations, okay, inode B initiate the initial UV message attach PDN request to the MME, this message. Okay. Okay, 1 minute. This message, you initiate this message. Now once MME receive this information, now what happened, first of all inode be checked whether this UV is valid or not. Okay, so now your authentication request happen. So here MME send the auth request to the HSS, this message. Based on that, so based on GUTI value or based on IMSI value, okay, now HSS calculate the calculate based on that K value, RAND, one random number, one authentications, and one XRES. Okay, those information we will see this information in our upcoming slide. Okay, then HSS inform this auth info to the MME. Then UV transmit MME transmit this auth request to the UV directly. Okay, so here inode be just bypass this information to the UV. Then here UV calculate the UV also authenticate the network. Okay, so in LTE your authentication happened bi-directionally. Inode B also authenticate the UV and UV also authenticate the inode B. Okay, now based on that authentication request, UV respond the authentication response to the UV. Then and only your security mode command message. Wait.
Sir, authentication will be in between UE and MME, no?
Yes, this authentication message is going between UV and MME only. Here, inode be just bypass this information. Okay.
Okay.
Okay. This is now UV send this. Once MME receive this authentication response, then inode MME send the security mode command. Okay, between MME to UV. Okay, so in which UV receive IK and CK value, ciphering and integrity value. Then based on that, UV configure himself and UV send the security mode command complete. Here now there is no need to it's not necessary each and every time we need to send the location response or location update. Okay, but still okay, wait. But still MME send the location update to the SSH. Okay, for the security purpose. So like if police want to track your location, okay, so in which cell and which area you are, so using these informations, police or other security teams can check your location. Okay, so this is not necessary, but sometime it's performed after once a timer is expired, like the timer value T3412 timer value, timing value is around 54 minutes. Okay, tracking area update timer. So in LT, if I remember, there are around 25 timers is there. Okay, so it's not necessary because inode B and UV have a different timer value, then inode B and MME have a different value, then UV and MME timer have a different value. So it's very hectic to remember each and every 25 timer. So once your UV send that location update message to HSS. Now, what happens after security complete message? MME send the session creation request to the SI gateway. Okay, this message. Okay, this message. Then based on that, SI gateway send that create a default bearer request. Okay, then SI gateway send this message to the P gateway. Then based on that P gateway, allocate the IP address for that UV or that session request. Okay, now your downlink data will start. Okay, based on that SI gateway SI gateway once received the create default bearer response, then it's forward the create session response to the MME. Okay, now your tunnel established between MME to P gateway for that UV. Okay, after establishing this GTP tunnel, just what happened, MME sent that initial context setup request to the inode. So here what happened, till now your security established between UV to MME, but there is one more RRC security mode. Okay, so in which now security IK or CK happened between UV and inode. One more time network send the RRC connection security mode to the UV, in which you will find the CK and IK value, then you will respond that RRC connection security mode complete message. Okay, now UV now network, once that RRC security mode complete message complete. Okay, now inode B send the RRC reconfiguration message. In that RRC reconfiguration message, inode B find the SRB2 value and DRB, respective DRB value. Okay, suppose in our case DRB4, if we give a value as a 4 for that DRB value, this DRB value used for the data transmission default bearer. So in if you learn about the QCI table, so sorry, quality of service. Okay, so different GBR and non-GBR traffic is there. So in non-GBR traffic, QCI 9 is used for the internet purpose, then QCI 5 is used for IMS signaling, QCI 1 is used for the VoLTE call, and QCI 2 is used for the your video call. Okay, so initially your data internet connectivity default behavior is established between UV and network. Okay, so now in this RRC reconfigurations, QCI 9 information is coming. Okay, so once UV configure itself with the respective SRB2 and whatever DRB assigned, okay, based on that UV send the RRC connection complete message. Then inode B send the initial context setup complete message. Okay, upon the request of initial context setup request, now inode B send the MMA. Okay, now UV is established with that whatever information GTP tunnel information you assigned to me. Okay, those information I pass to the UV. Based on that UV configure himself. Okay, Now what happened, MMA send the SI gateway to modify bearer request. Okay, upon this request, inode B sorry, SI gateway response, the modify bearer response. Okay, now your connection is established between inode UV to P gateway. So here from UV to inode B we have a DRB. Okay, then inode B to P gateway, till P gateway we have a GTP tunnel. Okay, this is GTP is nothing but it's a grounding tunneling protocol. Okay, so this is your call flow. So simply you need to describe this information to the interviewer. So now we are learning about whatever we learned. Okay, call flow, so in detail what happened exactly. So once UV power on, okay, then UV read the PSS and SSS. Okay, then after that UV select the inode B. Okay, in 0 step here it's written as a UV select the inode B. So that inode B select based on your first UV read, after reading PSS SSS, then UV read the MIP. So from that MIB value UV get the information about your frequency. Okay, uh, PHICH informations, frequency informations, number of antenna, and system frame number. Currently, which system frame number is ongoing. Okay, this information found from the MIB. After that, UV read the SIB. From the SIB, UV get the information about the PLMN, tracking area code, cell selection information, frequency band indicator. Okay, this is the TDD or this is the FDD, these informations, and scheduling other information priority. Okay, this all information present in SIP1. So in SIP1 initially UV required only PLMN, tracking area, and cell selection information. Once a cell selection criteria fulfill, then you will going with the frequency indicator and other frequency informations, sorry, other scheduling information for the other SIB. So here UV select, UV read the in 0 step UV already read the SIB1, and your cell selection criteria is met. Then now UV send the RACH request. Okay, from the SIP2, from where you will get this RACH information on which subframe, on which PRACH root sequence I need to use. From the SIB2 you will get this all the RACH related informations. Okay, so once UV power on and initially you will connect with the network, that time your CBRA, contention based RA perform. Okay, hope you understand what is CBRA and what is CFRA. So now you initially you will perform the CBRA, contention based RACH, and during the handover times contention free RA use. Okay, generally in initial and attach time always your contention base RACH perform. So in contention base we have a 4 message, in contention free we have only 3 message. So here we perform the 4 message at MAC layer. Okay, so I'll go through one by one. So once UV send the RACH request, so first message, in first message UV send the information about regarding the preamble ID. Okay, so you out of suppose network in SIP2 how many preamble we can UV can use for the contention base, and remaining uh, preamble used for the contention free. These all information present in SIB2. So now you will read the that SIB2. Based on that, randomly you will select any preamble ID. Okay, and it sends to the inode B. Based on that, inode B respond the respond the rar message. This is also called as a your message 2. So in this message you will assign some resource block for the message 3, temporary CRNTA value, and timing alignment value. Okay, based on that you will send the message 3. So now you will send the message 3 at MAC layer as a contention resolution request. Okay, and at RRC layer you will send the RRC connection request. Okay, both message transmit simultaneously. Based on that, okay, you will send the RRC connection setup. This is message 4. Here message 4, your temporary CRNTI assigned in message 2 is now converted in permanent CRNTI. Okay, and other informations like your contention resolution successful at MAC layer, your message 4, and also your message 4 at RRC layer is your RRC connection setup message, in which you are able to find the SRB1 informations. Okay, in SRB1 information, so it's include the PDCP, RLC, and MAC layer configuration for that SRB1, and other informations like channel informations, dedicated channel information. This all information present in this RRC connection setup complete message. Okay, this is your message 4. Okay, we have one more. Okay, so here I described in detail, like this is our message 3. Okay, after that successful complete, now you will send the RRC connection request message. In that RRC connection request message you will send the established cause. This could be MO signaling, MO data. Okay, then predefined configuration status informations, and domain indicator initial UEID. This ID is random ID. Okay, once once inode B received this message, UV so inode B send the RRC connection setup message. So in which predefined ID is there, default configuration mode, and default configuration identity, physical channel information. So this all information like SRB1 informations, your different channel configuration criteria, all the information is present in RRC connection reconfiguration, RRC connection setup message. This dedicated information is there. Okay, now based on that UV send the RRC connection setup message. This is your message 5, in which UV include the RRC transaction ID, UV radio access capability. Okay, this UV radio access capability is your network capability. UV can support what kind of security parameters and what are other features UV supported for with the MME. Okay, this information is present. Here in our message 5, you will send the piggyback message attach request as well as PDN connectivity request. So in that attach request, you will send the EPS attach type message, and voice domain preference, whether you will support the VoLTE call or not. All this information is present here. Okay, in this message. Now inode B send the initial UV context message to the inode B. Once just inode B pass this information to MME. Okay, so here once MME receive this initial UV message. Okay, now what happens, your authentication things happen here. So now first of all your network will check whether this UV is valid, or okay, any faulty UV is not there, like that. So for that UV send the authentication information request to the HSS. Okay, so now inode B send for that information. Inode B MME send the IMSI last visited PLMN ID, requested UTRA, and authentication ID. This information is present. Okay, in this ARI message. Then based on that, HSS checked in his database with respective IMEI. Okay, sometime Gutti value is also there. Every time there is no need to send the IMSI value. Okay, Gutti value also send here. MME also send the Gutti value to HSS. Based on that only, you will search the authentication ID. Okay, based on that, HSS responds the this message AIA authentication information answer. So in this, UTRA vector is present. So what kind of vector? Your random number, your resultant key, your authentication ID, and your KS means nothing but CK and IK value. Here what happens once MME receive this information. Okay, so now MME only send the authentication. In this authentication message, MME send only this rand and auth value. Okay, only these two number, rand and auth value. Okay, once would be send these authentications. Once you is check this authentications value and it compare with the resultant key. Okay, in upcoming slide we will learn about authentications. Then UV send the security setup. Then security setup information integrity protection and ciphering protection happen after authentication only. Suppose your authentication not happened, then UV again ratch with the network. Whole process start again. Okay. This is your authentication. What happened when UV send the IMSI value. Okay, so once UV send the IMSI value in attach request message only. Okay, in attach request Gutti or IMSI value is there. Okay, it's depend. If UV already connect with the network, that time UV send the Gutti value always. So now based on that, network have a see here is written decode the K parameter of the UV based on the IMSI. Okay, so this K parameter is stored in HSS. So from where you get this information? So once you buy the SIM card is registered in the operator when person purchase the mobile phone. Okay, that time this value is stored in HSS. Now based on that, network here network means HSS calculate the result MAC and RES based on the K and one random value, random number value is there. So random value that network decide, and authentication networks know. Okay, then network send only this rand and auth calculator to previous steps. Okay, CK and IK value not sure, as I mentioned in previous slide. Based on that, once UV receive this rand and auth value, so in UV SIM card also one K value is there. So here it's written calculate the same as network side by using the K. Okay, here in in UV UV SIM this in K value, this K value stored in UV SIM. Then K and rand and auth. Okay, based on this UV XOR this all the key, and it's checked the resultant key. Now you here UV check UV respond the resultant key. Okay, so once UV respond the authentication respond this resultant key. Okay, now network compare this resultant key with the XRES. So previously here network store this XRES. Once your XRES from the network side and RES resultant key from the in UV side both match, then and only your security part process here. Okay, after that you will send the security request, sorry, network MME send the security command in which CK and IK value is present, integrity protection and ciphering protection information is present, and UV send the security mode command complete message to MME directly. Then your updation location updation request happens. So MME send this value to the HSS, so in which your IMSI IMEI red type. Okay, which red type UTRA or and whatever with which PLMN you are currently attach all those information mme bypass to the hss. Okay, based on that hss respond the updation location answer in which msisdn, okay, your mobile number and apn configurations like internet, which apn you need to use, those information and quality of profile, p gateway allocation mode and context id. Okay, this all information is given by the hss to the mme. So here quality of profile, suppose if you buy a different plan, okay, you purchased once your plan expired, mobile data plan, so those all information is present hss, and hss get those all information from the pcf, sorry, policy charging control information, pcf. Okay, from that you will get hss get all the information. Once node b receive this step 7 value, okay, now mme create the session request with the SI gateway. Okay, so uv send the creates sorry, mme send the create session request to the SI gateway, in which this imz msisdn in your apn internet, pco, bearer context, bearer id, bearer quality of service, GBR, MBR, ECGI, and tracking area. This all information present in this create session request message. So based on that, UV first of all check the SI gateway check the PCRF with the credit control request, in which whether you are able, what kind of your subscription are there. Based on that, it's assigned the credit control answer where, okay, in which your pcc rules and your eps bearer quality of service information and maximum how much mbps throughput you can support at a time, those all information is present in the credit control answer or answer message, this 10 number. Then based on that, SI gateway create the sessions, and SI gateway responds to the create session response on upon a request of create session request. Okay, in this information create session response 11 steps here. SI gateway send AMBR aggregate maximum bit rate. Okay, how much downlink or uplink you can do based on subscription plan. Then your EPS bearer ID and other information is present. Okay. Now, once okay, once mme receive this create session response, uv send mme send this attach accept message to the uv. Okay, this attach accept message is a piggyback with the rrc reconfiguration message only. So what happened, mme send the attach accept message to the inode b. Okay, once inode b receive this message, so here inode b send the rrc reconfiguration message. In this message, this piggyback message attach accept message is there. So here in reconfiguration message you find the drb value and srb1 value. This srb1 value srb1 already you received in rrc connection setup. Here inode b send rrc in rrc reconfiguration message, inode b send srb2 mac rlc pdcp value and drb mac rlcp pdcp value. And from the attach accept message we can find that ambr and other timer value t4 t3412 timer. This is the your tracking area update timer, and other timer is there. Then tracking area list new good t in after every attach. Okay, network assign new good t. Then esm message container and your CQI value, your PDN address, and PCO. In PCO, we can find the IP address and APN AMBR quality of service. Okay, based on that, UV respond the message 1.3. Okay, attach accept. Okay, this information also is piggyback with the RRC connection reconfiguration complete message. Okay, So you once UV send the RRC connection reconfiguration complete message. In that piggyback message, UV send the attach complete message. Then once UV receive, sorry, inode B receive this message, inode B just forward the attach complete message to the inode B. Okay, once MME get to know, okay, now UV is send me the attach complete message. Okay, then MME send the 1.4 message to the like a modification modify bearer request. Okay, so now Sci Gateway establish the GTP tunnels between Sci Gateway to inode B. Okay, this DLS1 bearer establish this message. Once inode B once Sci Gateway receives this modify bearer request, now Sci Gateway establish the tunnel between Sci Gateway and inode B. Okay, and Sci Gateway send inform inode B that okay, I already established a tunnel with the respective inode B. So for that modification bearer request response, inode B Sci Gateway send the modify bearer response, in which you can find this information. Okay, and now your end-to-end bearer is completed. EPS default bearer for the default EPN is completed. Okay, so now this all information pass when UV is power on and UV is attached with the network. Okay, this is for the data only. So in tomorrow session we will learn about after this, once UV establish the a second default APN for the IMS. Okay, this all information we will learn in upcoming session. Okay, till now anybody have any questions? You can ask me. Hello.
Sir, I have a question.
Yeah, tell me.
Sir, you said that every time device you attach to a new inode B, a new Booty value is created.
Yeah. So
So
once UV successfully attach with the network, okay, in with the any inode B. If I'm telling inode B, okay, so in telecom domains, everybody use this kind of term: network, inode B, or RAN. Okay, so once it's talking about these three value, you just understand inode B, because UV primarily connect with the inode B only. Okay, so after every attach complete, network assign new good thing. Yeah.
so even if that U is attached to that inode B before also, then also a new boot will be created.
Sorry.
ऐसा मतलब इनोड अगर वो यूई पहले भी वो इनोड बी से कनेक्टेड हुआ होगा पहले कभी, तो भी
Yeah.
नई यू की वैल्यू असाइन की जाएगी या पहले वाली कंटिन्यू होगी मतलब?
No, no. So what happens with each and every attach? Okay, as I told. So here, what happens once UV attach with the same inode B or other inode B? So after every attach complete, network assign new GUTI. This new GUTI is a unique with respect to the network. Okay, so this GUTI, network cannot assign this GUTI to other UV also. So that's why with each and every attach complete, okay, network assign new GUTI, and this GUTI UV is used for second attach. So suppose in some case, like आप जब शाम को सोते हो, ओके, तब आपने ऑलरेडी कुछ चैट वगैरह कर दिया है, तो आपका अटैच कंप्लीट, वो टाइम पे आपको एक गुट्टी मिल गया रहेगा. ओके, देन वंस यू आर स्लीप, देन मॉर्निंग में जब आप उठते हो, तब अगेन यूवी एक बार अटैच मारेगा नेटवर्क से. ओके, जैसे ही आप लॉक खोलोगे तो आपको मल्टीपल मैसेज मिलेगा हर एक डिफरेंट डिफरेंट एप्लीकेशन के थ्रू. ओके, so he UV again attach मारेगा with network के साथ. So here UV in attach request message UV send old गुट्टी. आपको जब शाम को जब सोए थे, जब आपको जो भी गुट्टी मिला था, वो गुट्टी अभी अटैच रिक्वेस्ट में भेजेगा. एंड इन अटैच एक्सेप्ट अभी क्या करेगा, नेटवर्क एक
जो
नया
भी
गुट्टी
प्रोग्राम
असाइन कर देगा. ओके.
ओके ओके यस सर
ओके.
ओके सर
ओके, एनीबॉडी हैव एनी अदर क्वेश्चन? Everybody is silent. Are you able to understand whatever I teach you?
Yes, sir.
Okay, so I don't have a logs right now with me. Otherwise, I can go through logs only. But once you have a logs, okay, our team also sharing with you the logs. Okay, so in which you can find this all the information. Suppose here in RRC connection request, your establishment cause. Okay, this will if you open RRC connection request message. Okay, let me show you from the internet only. This is your SIB1. Okay, so in SIB1 your PLMN information is present, whatever PLMN information. SIB is look like this. Okay, here is your tracking area code, cell identity, and cell selection criteria, and here some other SIB information. Okay, in SIB2 you will find the RAG configuration and other channel common configurations. This is common for the all because here UV is not attached with the network. So in SIB2 only common information is going through from the network. Then UV timer related information. So here if you see in SIB2, this is SIB2. So here RAG configurations configuration is there, in which required informations, like it's not necessary in first attempt RAG only UV is connect with the network. So suppose once UV send the message one preamble. Okay, and there is a 10 millisecond time window is there to receive the message too. If this criteria is not meet, then UV ramping the power. Okay, initially we assigned the minus 104 dBm power to the UV to send the message one. Now UV increase the power level value with the 2 dB, like minus 102. Again UV send the message one to the network. So this all information is present in SIB2. This is the in SIB. Okay, this is your message one. So if you decode your message one, you will send the preamble index, this 15 value. Okay, this preamble index is the preamble only. Then based on that, this is your message two, in which you can find temporary CRNTI. Okay, here, then other uplink grant. Okay, this information. Then your RAIP rep ID. Okay, so suppose sometime what happens, network send RAR response. Okay, here UV send the preamble ID here 15. Okay, but suppose in some case network send RAIP as a 16. Okay, this means your RAC has some issue. So now L2 engineer check this and decode what is the coding issue. Based on that means how to say. Okay, so if you are a protocol engineer, okay, and you are testing some test cases, so in which you need to check whether UV is attached with the network or not. So now UV send the RAC request, and you are also receiving the RAC response, but your message 3 is not UV is not sending the message 3. So what could be the possibility? So for that you need to check whether my rep ID. So rep ID is nothing but your previously preamble. Okay, whatever preamble you send, so you can we can send any preamble out of 64. Okay, so suppose you will send preamble number 1 to the network in message 1. Based on that, your rep ID should be 1 only. Okay, it should not change from 1 to 2. If your rep ID change, then you will not send message 3. So this kind of testing you need to do, and this kind of analysis you need to do as a protocol engineer. Okay, and this is message 3 and message 4, in which see, this is RRC connection request message. Here one random value, UV identity and establishment cause, MO signaling, Then this is message to in which your SRB1 is present and other common information is there. Okay, this all information present in RRC connection setup. Okay, so once you have a logs in which you can find all this type of configuration. Your this is your notch attach request message and PDN connective. So your attach request message it look like this. Okay, here is the security UV network capability. This information is present in which whatever algorithm is supported. So this is supported by the UV, these three, and this is not supported by the UV. So it's mentioned over, it's not supported. So those this all information is present. Okay, you can refer these informations. As I don't have a message or any logs, though I cannot teach you everything in detail. And nobody, remember each and every I. If you notice in this message, okay, this attach request message only if you calculate the each and every I, okay, so around 200 I is there in this attach request message only. In SIP2 also we have lots of I, so nobody remember each and every I. But from the like once you experience, okay, so suppose if you want to find the ratch related information, okay, so that ratch related information you can find from the SIP2 only. Okay, so you always look SIP2 for the ratch related issue first of all. Then uh, other A1, A2 and A3 information. Okay, for that you always look those information in RRC reconfiguration message only here. So here your measurement configuration ID is configuration in which this mobility in this two message you have around 500 Is. Okay, this is not extracted here, that's why. But here you are configure A1, A2 and A3 event, A4 event based on your requirement. And as I told in piggyback message, okay, this is the piggyback message. So this is NAS container, this is your attach accept message from the network side. So inode cannot decode this message, UV only able to decode. That's why inode and this RRC reconfiguration in which they include the piggyback message attach accept. Okay, this is the your dedicated information NAS container. Once UV decode, okay, then based on this UV attach UV receive the attach accept message. Then your DRB and SRB information. See, for each SRB and for each DRB have a logical channel configurations and RLC, PDCP, and every configuration is present here. Okay, so this is it. Anybody have any question? You can refer this LT call flow from Share Techno. Okay, so from that you can learn about this. Anybody have any other question?